going to the gym is good, but
Well, no, he was
but like
skipping, or he was late to practice a lot though.
but you don't go like, I mean, it's kind of boastful to be like, dude, I'm gonna be so good this year. Who says that? It's like, I'll believe it when I see it.
Pro maybe, but not nice.
Even as a pro, that's cocky.
I don't know, a lot of people made a redemption. Come back to the game.
Oh, dude, Kate, I feel so bad.
Did you see the X-ray?
No.
The X-ray is horrible.
Well, I should say you can sit wherever you want as long as you're 3 feet away. So go one down.
And you should right there. Just drift it away.
That's 3 feet. That's 3 feet.
Dude,
That
We
was
should go to the game on Saturday, Shop. Play one a key.
I'm going out of town for Easter.
that's the X-ray.
yeah, and then that's the skin. He had to get surgery so it didn't like pull through.
The collarbone. Not injuries, horrible.
Oh, what?
He'll be back next year.
Oh, I forgot that home.
He'll be playing for his spot. Because people in line will take.
It's fucking fun.
You better heal up. How long is that?
He'll be up for it.
Collarbone?
Yeah.
Yeah, 6 weeks.
Yes.
Mm-hmm.
We're not having homework, are we?
I think that'd be a great idea.
Yeah, great, because I like to do some.
Oh yeah, I didn't really hear what you said about the homework pass for our other assignment. Do I just give it to you or?
Yeah.
Can
Just
I
fill it
email
out.
it to you? I forgot it at home.
You can email it to me.
Should I fill this out?
Yep, fill it out for what assignment you want.
Sure, we can fill it up. We'll do that.
We got 1 more minute. Where is everybody?
A lot of people aren't filling it in. That's what I figured out in my other class.
It's so empty.
Yeah.
Like, I got out of my second class, or my third, and no one was in the class. Oh, shoot. What? My pencils and stuff are in my-
As long as we got Mason, we can hold class. That's all that matters. Rouch is zoomed in, so we're good. How you doing, Mason?
I'm good. How are you?
Doing all right. That is the bell. So we'll let Milam in and Blake. We will let Herberger and Fries in. Okay, so today, I think you Zoomies, you are going to be watching some videos by Tyler DeWitt. However, looking at my list here, Blake, you need to do the lab. Defina, you need to do the lab. Milam, you need to do the lab, and Wapia. So that means only Mason, Zane, and Blake, you 3 will be watching the videos. So I'm just going to show you where those videos are to make sure you know what you're doing. Blake, Defina, Milam, and Wapia, I'm going to show you where the lab is. So I'm just going to share my screen. Why does it say I'm muted? Unmute myself. I am unmuted. Okay, so let me share my screen. So under gas laws, if you scroll all the way down to the bottom, there's the molar mass of butane lab. So you're going to click on that, and then you'll have the document that you can download into Notability, or you can print it off and take a picture. That's up to you. Okay, so that's where Blake, Defina, Milam, Antonio, Wapia, you guys are going to, and Defina, that's where you're going to get your lab from. The rest of you, are going to be watching these 3 videos, and I'll put that in the chat room. So you can be watching Tyler DeWitt gas pressure, Tyler DeWitt ideal gas, Tyler DeWitt ideal practice problems. There's 3 of them, and they're about 10 minutes each. And then you'll do the ideal practice problems. So I'm just going to put that in the chat. And then for homework, okay. So I'm going to stop my share. And then I'll just make sure everybody knows what they're doing. So Albie, you're doing the lab with us. Antonio, you're doing the lab with us.
Right.
Blake, you're doing the lab with us. Defina, you're doing the lab with us. Gerald, do you know what you're doing?
Yes, I'm looking at the videos.
Yep. Hey, Burger, you know what you're doing?
Wait, Mr. Strauss,
Yep.
aren't I doing the videos?
Yeah.
Or is it the other?
Yep. Herberger, you're doing the videos.
I
Mason,
just needed to submit my lab.
yeah, you can do
I
that.
finished and everything.
Okay.
I just submitted it.
You guys can be quiet just for a sec. Mason, do you know what you're doing?
Yeah.
Okay. And then Zane, you know what you're doing, right?
Yeah, I'm good.
Okay, so I will mute myself. Actually, I'm going to switch over to the iPad. I'm not going to mute myself because the rest of you guys have to see the lab, and I'm going to be videotaping the lab so that you can get the data. All right, so let me switch over to the iPad.
What lab is this?
Okie dokie. So let me hand out the lab to these fine people.
Sir, lab time, let's go. Gee. Very excited. Yo, let me switch my. There's a lot. I like not. Ask him. I already did. Try, you don't think over it? I turned in my portfolio stuff. That's all I have.
All right. Okie dokie. So there's 6 of you, right? So you can go to, there are 7 sinks. 2, 2, 2. There's 1 sink over there. Okay. So 1 person to a sink and get a lighter. And so the first step is to weigh your lighter, right?
There's no.
So I'll stop bouncing this thing around here. I'm gonna set it up right here. So you can watch this lab station. So 1 person to a sink.
No, you can go. Oh, I can go over there, but there's no scale.
You got one.
There are balance, there's balance here, balance there, so get a lighter, wait, here. You have to come on over here. Get a lighter, weigh it, and stop playing with it once you weigh it.
Yeah, cold.
I don't got, I like that. You go to the gas station,
No, I want to.
that's the way.
So Amir is going to weigh the lighter. I know you can't see that, so we'll wait till Amir is done weighing it. Come on, Amir. So for some reason, he decided not to write down the zero, even though it clearly says zero right there. Always include all the digits. It's more accurate. Okay. So once you weigh it, don't play with it anymore to let the gas out. So now you're going to collect 200 milliliters of gas. You're gonna fill up, it says to fill up your cylinder and collect 200, about 200 mils of gas. This ain't rocket science. Weigh your lighter and then fill up your cylinder, collect 200 mils of gas in it, right? You can't read, right? You can read the directions from the lab.
It's just gonna come out of the beaker when you put it in.
So,
Yeah.
So you hold it upside down.
yeah, you fill up the beaker and turn it upside down.
Yeah.
You fill the entire graduated cylinder with water, turn it upside down, and then release the lighter. No, just read. You guys are like, you're like little big babies. Read. I'm not going to answer questions. Read.
If we fill it with water and turn it upside down, the water.
Okay, let me fill it up with water.
This is the advanced class.
Yo, Mr. Strauss.
I'm coming. What's up?
Could
You might
mute
wanna
your,
roll this
thing?
You want me to move this?
No, could you mute it?
No, I didn't mute it. No,
Oh,
I'm not gonna mute.
all right.
So fill it all the way up and then turn it upside down. Make sure there are no air bubbles in there. Get it complete, get the graduated cylinder completely filled. Now turn it upside down in the sink. It's all falling out. That's no good.
Oh, no. It's called gravity.
That's right. You want it all filled up and then turn it upside down in the sink. Alexis is onto something.
Oh,
Yeah.
okay.
So now that you've got it completely filled, then you hold your lighter under here and collect about 200 little bits.
Gee, I failed.
But I find amazing, it's not so much amazing, that no one wanted to read, everybody just looked at Alexis.
Yeah. That's all right.
I'm not gonna read, I'm just gonna wait till someone else figures it out and copies that. That's human nature.
Oh.
So now it's filled with water. And then Amira is going to collect about 200 mils of gas in that graduated cylinder. You just put the lighter under water and you don't play with it. Now your mass is all messed up. Now reweigh it. You weighed it and now you just let gas out into the air. So now reweigh it. No, that balance sucks. It's a real balance. The same word. No, that's because it's a crappy balance. Go over the one that I like. This thing only weighs up to 10.
Oh.
The more vertical you hold it, the better.
Lighter?
Everything. It'll go faster. Not that it's important to go fast, but, and then when you're done, if you want, we can light the butane gas on fire.
What?
You want, you don't have to.
Mr. Strauss, I don't know how lighters work. What do I do?
Okay, so, let me, so you just press and hold down, and then the gas will come out.
Okay.
Yeah, that shit hurt.
This part? Okay.
Yep, it's probably the most practical thing you can learn in my class. Just put your thumb on the top,
Uh-huh.
roll it down and hold it.
Under the water? or
Under the
over?
water,
Okay.
under the water.
Okay.
Kind of hard shot.
You're doing great. Just make sure you don't pull the cylinder out of the water.
So how do I know when it's up? When it hits
You're
200?
ready. Once you get 200, then call me over. Okay? You get to 200, call me over. Don't pull it out of the sink. Exactly. You can see the gas bubbles filling the cylinder. Cool. You can do this at home.
It's taking forever though.
Don't blow up your house.
Why not?
So my daughter was afraid of like being in her room. So I was telling her like, your house is the safest place you'll ever be. Okay? Like your house, there's nothing, your house will be the safest place you'll ever be. That one house over in Fitchburg blew up. It's like basically 2 blocks away from us. We saw it blow up. So I'm like, all right, well, that really kind of keeps that. I'm telling my daughter it's the safest place you could ever be, and then this house blows up.
Oh, what were you getting into? Already, I was so focused.
200.
About 200. Yeah.
I'm only there. But that's not 170. No way. Yeah. I'm only at like 100. 190.
No, he's just texting.
Yeah. Like 200.
So. So you see how the water level's higher? So what that means, air pressure is stronger and pushing the water up inside, okay? So if you get the water level inside and outside equal, then the pressure inside and pressure outside. Okay? So it looks like you collected about, yeah, so like 200.
170.
Write that down, let's divide collected.
170.
For divide heat and gas collected. Yeah. Okay. So butane gas is denser than air. So pull it out, count to 5, and then put the splint in there. And let it fire.
Wait, am I at 200 or?
No, you're not at 200.
I'm at like.
It's gotta be on fire. Did you pull it all the way out?
Okay, now am I doing?
Yep, so pull it out. Right. Yep, pull it out. And then count to 5. Oh. Wait, yeah, put it in right in. Oh, no, no. So that's your line. Dry it really well and Make it 200. What do you mean, looks like? Read the numbers. Okay, 200. All right, so see how the water level is higher? So that means the air pressure outside is stronger. It's pushing the
Alexis,
water
bro.
back in.
Alexis,
If you get the water level inside and outside.
Alexis. Alexa.
Yeah.
Now the water level
Bro, you have
inside
to
and
you have to
outside
get your lighter up so make
now
you go
means the
faster.
pressure
Watch.
inside.
So put your lighter like straight.
So.
You should put your lighter straight so
Let
you
me get
go
it.
faster.
Oh, that's good.
Did you weigh it yet? Hold on.
I can't even see the water level right now.
Try?
Oh no no.
Now it's dry. All right. Make sure you shake it really well. No, but here's the lighter. Well, let's see. Sure. So right now the water level is high, right? So that means the air pressure outside is stronger. It's pushing water. Okay.
Let all the water
You've
out.
got about
Yeah.
that's 190, that's 200. So that line right there is 200.
Yeah.
Put it in 202, 204,
Wow.
206.
Oh, what is it, 200?
Yeah.
Yeah, can I comment on?
And then that's the heat.
That's the, oh. we'll take-
No, yeah, I did it like.
Yep, dry your lighter and weigh it.
I did.
Okay. Did you really? So if I do this. Okay. Hold on here. Okay, so Amir is just about ready here. And so what I'm gonna show you is, I got it. So you see right now, the water level is higher. Okay, you see that? Defina, Wapia, Milam, Blake, Albie. Because the water level is higher, it means the air pressure outside is stronger and it's pushing the water of the sink up into the cylinder. If I get the two equal, so right now the water level inside and the water level outside are equal, then I know the pressure inside is equal to the pressure outside, okay? And just kind of looking at how much gas he's got in there. I know it's kind of hard to see, but that's 190. That is 210, 212, 214. So you have 214 milliliters of gas, okay? So let's write that down on your paper.
Where's that?
So volume collected.
It's 214.
Okay, so make sure you write down the volume of butane collected. And now let's get your lighter. Dry it off really well. Then shake it. Get all that water. Come on, that's the wimpy shake. Look, come on, shake it. There you go.
Okay.
So now that Amir is shaking it, he's gonna dry it. I mean, weigh it. Oh, this balance is. Okay. So let's write that down.
You do it, it's your experiment. Now let him do it, let him do it. He's gotta do it.
Amir, I don't think this balance was working beforehand. Because this was like this, and just, so. Just make that 15, okay?
15.
All right, so everybody at home, we're going to use someone else's data here. So
I had to write with my left hand, so this is 200.
so let's just take a look see here.
I think I got pretty close.
202. Okay,
Yeah.
here, you wanna hold that?
Yeah.
So everybody at home, I'm sorry, you're gonna have to change this. Wait, mass of the letter was 15.00. Why do you guys not write down zeros? The balance says 0, write down the zeros. So Albie, Defina, Blake, Wapia, Milam, Antonio, write down this data instead. So erase that other data and write down this instead. And this is milliliters. So if you want to light it, you can light the gas.
Oh, that,
I do not want to.
You don't want to?
No,
That's fine.
I don't like
Then I
fire.
will.
Well, let me do it.
Yeah, someone
Okay.
else can do it. I don't like fire.
All right. So I'm going to do this. So just for fun, I'm going to light the butane gas on fire. Butane is denser than air. So the butane is going to fall down into the sink. So I'm actually going to light the sink on fire, not the, yep.
I wanna see this. Strauss might be cool. Might be
How can we do this?
So I'm going to pull it out here and let the whole sink fill with gas. Oh, it went out.
cool. You're lying.
Oh, no.
Happened.
My
whole
splint is
sink?
wet. People throw these,
No one.
yeah, people throw them in the sink and then they get wet. All right, there we go. So 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000.
Holy.
You can't blow through a mask. Just realize that. All right. Well, if there's time at the end of class, we can. So why don't you guys come on back? It looks like a lot, but it's just a lot, so. All right, I have to write down the data from Julia. So you guys can write down the temperature of the water. It's 18 degrees Celsius. It's about 66 Fahrenheit. So I rewrote this lab. So what you have in front of you is just a teensy weensy bit different than mine. I provided a line for temperature. I created a line for barometric pressure. I put the line in. So like that's the only difference between my lab and your lab.
We have that.
Oh, you do?
Yeah.
Oh, okay. Then I must have printed out the new ones.
We don't have the volume. Oh, yeah, we do. I do.
Okay.
I know. I have the volume.
So, but the rest of it should be the same. All right. So I just want to go through my list here. Make sure everybody's ready. Albie, you ready?
Yeah.
Antonio, you ready?
Yeah.
Stefina, you ready?
Yeah.
Roberto, are you ready?
Yeah.
Milam, you ready?
Yeah.
And Mapia. Mapia, you ready?
Yep.
Okay. So the first thing we're going to do is calculate how much gas was released. So we're going to take basically the before minus the after. Okay. Okay, the before minus the after. Does everybody have a calculator? One? Josh, you need one? Yeah, but do you need a calculator? So that's the mass of butane released. We're gonna come back to number 2. We're gonna jump down to number 3, okay? Convert the milliliters to liters. So everybody, well, all the Zoomies have the same number, 202, but the people in the classroom, everybody's got a different volume, right? So you take your volume, and if I've got milliliters on the top, I put milliliters on the bottom. I convert the liters. When we go to my volume expert, Brian, how many milliliters are in a liter? And that tiny voice you heard whispering was his conscience. So we convert it to liters. You didn't see this, but I took the temperature of the water. The temperature of the water is the same temperature as the air, okay? Because I filled these sinks last night, so the water temperature is the same as the room temperature. So the temperature is 18 degrees Celsius. We had 273 to get it into Kelvin. That's a 1. My fault, 291, 291. In step 5, we're going to use this equation to find the moles. So we're going to have to do a little bit of algebra. Divide each side. Actually, I'm going to use a different color. Divide each side by RT. So that way we get PV over RT is equal to N. This is our volume. That's our temperature. And our R value is going to be 8.31 liters times kPa over mole times Kelvin. Okay? Well, Pia, just an FYI, your microphone is not muted. So if you say something, make sure it's very complimentary.
Okay, thank you. Sorry, I didn't see
Like
that.
if you want to like mumble under your breath how awesome of a teacher I am, that's totally up to you. You know?
Just imagine if she did.
You know, you can always do that. Be like, whoops, I'm sorry. I didn't realize I was complimenting you out loud. Just kidding. So we've got V, we've got T, we've got R, okay? What about P? What about our pressure? Okay. Well, I rewrote this worksheet and I realized some mistakes I made. And one of was I didn't give nearly enough space for you guys to do your work. So you're just going to have to write this in the margins somewhere. So I apologize. I'll fix it for next year. So when you're taking this class next year, Cole, it'll be much better. That's true. But some people like to be on the 5-year plan. You did it to yourself. What, you can't read I mean, that's what the syllabus is there. I mean, what the prospectus is there for.
Well, it's not on the app, though. You have to go into like the website.
So I'm drawing the sink is what I'm doing, okay? And then here's the graduated cylinder. And then we've got this, okay? We collected butane gas inside that cylinder, okay? Now, how can I figure out the pressure inside that cylinder?
The same as air pressure.
Wow, good job. That was the whole point of making sure the water levels were equal. Because if the water levels are equal, the pressure inside is equal to the pressure outside. And so then all I have to do is go to my friend, Siri. She's my friend. At least that's what she tells me. I'm going to ask Siri, what is the barometric pressure in Verona, Wisconsin?
The barometric pressure is currently 30.54 inches of mercury.
She's nice. So there's my barometric pressure, 30.54 inches. And so, Roberto, that's great that she told us the barometric pressure, but the only problem, Roberto, is that we don't use inches in science, 30.54. I'm going to have to convert this to KPA, because KPA is what we use in science. So, but don't worry, you guys took unit analysis back in September. That was the first unit we did. How to do, so 34.54 inches. Where are we going? KPA. So write down where you're starting. Where are you going? So if I have inches up here, Amir, what's going to go down there? Yep, inches. So whatever up on top goes down the bottom. I'm going to convert it to centimeters. 1 inch is 2.54 centimeters, okay? You just look that up, or if you're a geek like me, you memorize it. So we convert from inches to centimeters. Boop, boop. Then we're going to convert from centimeters to millimeters. So if I have centimeters on the top, centimeters on the bottom, and how many millimeters, Julia, are in a centimeter? Don't make me cry. Don't make me cry. You don't want to see a grown man cry on the last day of school. No. So kill hairy ducks but drown certain mallards. It's base 10. Centimeters are 10 times bigger than millimeters. So now I'm going to go cry. And you're going to have to live with that for the rest of your life, that you made me cry in class. I believe it. You made someone cry, Brian? All right, we got millimeters on the top, put millimeters on the bottom. So we're going to convert it to KPA. and the conversion is 760 millimeters of mercury is 101.325 kPa. Okay, so this conversion is the same for everybody because we're all doing atmospheric pressure. Okay, you just multiply everything on the top and divide by everything on the bottom. That cancels, that cancels. That's what my calculator tells me. 4 sig figs, 3 sig figs, 6 sig figs, 3 sig figs. So I'm going to round to 3 sig figs. 3 sig figs will be 103 kPa. So that's my pressure. Okay. So I just want to give about 30 seconds or a minute here to make sure everybody's got enough time. Just remember, don't log out early because if there's time, Alexis promises going to sing us his favorite songs from the musical Cats. It is quite the performance. How are you doing, Albie? You okay? Antonio, do you need any help?
No.
Defina, you okay?
I'm good.
Roberto? Milam?
I'm good right now.
Lupia?
I'm good.
All right, so let's move on to the next part. So we know the pressure now inside our graduated cylinder. But here's a little problem we have. We collected this gas over water, and water likes to evaporate. So we have a little bit of water vapor in there. The pressure, the total pressure inside is equal to the pressure of the butane gas plus the pressure of the water vapor. You know from experience that if you take a hot shower, the bathroom gets all steamy. That's because hot water evaporates really quickly. Cold water evaporates slowly. So there's not a lot of water vapor in there, but there is some. So we have to subtract off the water vapor pressure. Okay. So this expression here is called Dalton's law of partial pressures. The total pressure is equal to the sum of the individual pressures. So just go ahead and write that little equation down. So the total pressure inside is equal to the pressure of the butane plus the pressure of the water vapor. And again, I'm sorry I didn't leave space to write this. I'll fix it for next year. So you just gotta have to squeeze it in wherever you can.
What does that second thing say?
It says water vapor, H2O vapor. So Josh, when you collect a gas over water, it's called wet gas, okay? So did you collect your gas over water? did you have that cylinder in a sink over water? So you have wet gas. Okay. We've got two unknowns. So how can we solve for this if we don't know the water vapor? Well, that's where your book comes in. So on page 360 in your book, if you don't have a book, grab a book. There's a book there. There's a book behind you. There's a book. Page 360. There you go. So you go to page 360 in your book. And there's vapor pressure of water table. Hot water has a big vapor pressure. Okay, so water that's almost 100 degrees Fahrenheit has a vapor pressure of 7.4. Our water was pretty cold at 18 degrees Celsius, so the vapor pressure is 2.1. Not very big, but still a little bit of pressure. So for us, (2.1 kPa). So the water vapor pressure is 2.1. Everybody's sink was the same temperature. Some years I make all the sinks different temperatures so that everybody has a different vapor pressure. For people I don't like, I make the sink, I mean, for people that are, so sometimes I make the sink with ice water. So then you got to hold your hand in ice water. Other sinks are like at 45 degrees Celsius, so just on the threshold of pain, not quite pain, but just right there. So, but this year we just did it all the same temperature. You got, well, I like you. I mean, I did it. Yeah, you guys are good. All right. I'm not recording this, I hope. All right, so now let's solve for the pressure of butane. And this number is going to be the same for everybody because we all have the same atmospheric pressure and water temp. So 100.9 kPa, that's our pressure. So now we know everything we need. So you know your volume, you know your temperature, you know your pressure, you know your R value. You have all four things there, Amir. You can now plug it into that equation and calculate it, okay? So go ahead and calculate that. I'm just gonna stop sharing my screen for a second while you guys calculate that on your own. Okay, I'll hold up. You need a calculator? There you go, sir. So pressure. Volume. So KPA cancels with KPA, liters cancels with liters, Kelvin cancels with Kelvin, and we're left with moles of butane.
So I'm pretty sure we all got, or at least I got a big number. How would I, like, would I simplify it?
Let me see. Your number should be about.
I got like 0.0008.
Oh, yes. So 3 sig figs would be 0.00859. Is that what number is that? Oh, that's a 5. So then rounded up to point, it'd be 860 then.
119.8. You have to times the top numbers and then times the bottom numbers. Divide both. That's like because you forgot to put Kelvin on the bottom. So it should be 291 on the bottom.
It is.
Oh, flip it around. 8.31 is at the end.
It wouldn't, it's multiplication, it doesn't matter what form it's in.
It doesn't matter which one comes first.
Yeah.
So,
Then you just put something around it.
is that 200 or 0.2?
0.2.
So actually, that looks right.
And I got 119.
So, well, you definitely 20.18 divided by.
240. 2418.
Why I can't see it.
What the?
I don't know how to use a calculator, right?
I did that. I literally did the exam.
Mason, you need some help?
Way too high.
What did you put like that?
You got like 720 something.
What?
You got 720 something.
Divided by. That's right. Oh, you forgot that, no, it's gotta be milliliters, point.
That's our 112.
So it just works.
What is that?
8.42.
Oh, okay.
I mean,
See what I did?
what I had to do was just times the top number, see the number, times the bottom number. That's kind of
Yeah.
funny, but
All right, just took us a little bit longer to calculate there. So using your data from number, oh, we got to share. Yeah. Oops. All right, so number 6, we're going to calculate the molecular mass. The molecular mass is the number of grams divided by the number of moles. So the number of grams we got in step number 1. Problem number 1. So that's my grams, whatever you got for number 1. That's going to be different for everybody. And then divide it by your moles from number 5. Three significant figures. So I got a molar mass of 43.3. Yours is probably gonna be higher, Amir. My guess is like 80 or 90. So the number of grams is coming from number 1. and the number of moles came from number 5. Those two numbers. Okay. How'd you do, Cole? Still calculating. So now what we're going to do is so this is the experimental. That's what we got in the experiment. Now, how close did we get to the real value? Well, butane is C4H10. That's the formula. So it's been a little while, but let's calculate the molecular mass of butane. So what is the molar mass of carbon, Alexis? What's the mass of carbon up there? The periodic table. Okay, Alexis said 12, and we got 4 carbons, so 12 times 4 is 48. And what's the molar mass of hydrogen? 1.01, and we've got 10 of them. So the theoretical value is 58.1. I got 43. Josh got 36. So the last thing we're going to do is we're going to calculate your percent error. And that's E minus T divided by T, absolute value, times 100%. So what you got in the experiment, it's your experimental divided by your theoretical times 100%. Anybody at home have any questions? No, because you take absolute value, so it makes it positive.
No, I'm good.
We really want to.
How do you get absolute value?
So you typically you just do it in your head.
It's just absolute value.
So like if you do 37.8 minus 8.1, so you come up with a negative, just press that button and it'll make it positive.
Oh.
And then divide by the
So can I
58.
Didn't you already do that?
Yeah, I already did it for you. So yeah, divide by that times 100. Yeah, so you can just write it as or you can just write it as a positive value. That's the other thing you can do. You can just write it as a positive number. Okay. So next year I'm going, well, let's be less confusing. You do not have to do any of the analysis questions or the discussion. So you don't have to do any of the analysis or discussion. Next year students will have to. So it's something you can look forward to.
Yeah.
But this year you guys don't have to do it. So when you're done, just take a picture of it, upload it to Canvas.
So what about the mass of butane released and another one? Does that not matter?
So we calculated it. This is the mass of butane released. That's how much butane you released.
Okay.
So just a reminder to everybody, if you want to, I've got all the rest of the units in Canvas. So if you want to study the things that we didn't get a chance to study, you can. I know it's been kind of a weird year, obviously, but I appreciate you doing your best. And you can always stop by my classroom if you need help on anything. But have a good Q4. I will grade these this weekend and I will update your grades. So if there's a problem, let me know. But remember that, like, if you didn't do a homework assignment, I put in an alternative assignment. Because every year there's like one person who comes in like 3 weeks from now with all their assignments and say, oh, here you go. And I'm kind of like, how did you do an entire semester's work of work in 2 weeks? Like, that's impossible. If you could do a whole semester in 1 week, school would only have to be 2 weeks long. So just realize the assignments are locked, and I give you an alternative assignment because I want to make sure that you're getting in good practice. Okay. I will stay on the Zoom after the bell rings just to make sure that everybody at home has got everything good. So then you just make it possible 15%.
Thank you.
What about the barometric pressure?
The barometric pressure was what we 103 kPa, what we calculated right there. Unfortunately, it doesn't look like we're gonna have time for Alexis to sing his favorite songs from the musical Cats. I'm sorry, Alexis. Next time. He was rehearsing before class started and just let him down again. Good luck. No, you don't need luck because you've been practicing. You know, I walk the soccer fields, like the borders. I didn't actually walk on the field. Part of me gets really jealous because, like, you guys actually have real soccer fields. When I was playing soccer, they didn't care about soccer. We were always thrown on like some weird field. There'd be holes and divots. There'd be like gopher holes. I'm not kidding you. Like, I never knew what it was to play on a real soccer field. I remember one time we played on a real field in Brookfield. I'm like, oh my gosh, the ball goes straight when you kick it. See you later.
Mr. Stoics, I sent you a chat message.
It didn't pop. Oh, because you sent it to my iPad chat.
Yep, sorry.
No, that's confusing for me sometimes. Oh, I gotta see. Did Milam want to get back in here? Yeah. Okay. I'm getting there, Albie.
That's fine.
All right. No, leave the volume in decimeters cubed. Don't convert it. And
Did I get the right answer? Because I think I used the right R value for if it's converted.
Oh, let me just see here. PV equals nRT, PRT. Let me look at the problem. You should be off. That should not be the right answer. Let me just, I can just work it out for you real quick. Okay.
Sorry, I was muted. I used the R value of 8.3. Shouldn't it be in?
So 1 decimeter cubed is a liter. So you got PV.
Let me
equals
just
NR
get screen recording going here.
Oh, sorry, I gotta get the screen up for you. Oh, I got my, you can see my screen, right? Yeah.
Yeah, I can use screen. I just wanted to record it so I could look at this later.
Oh, yeah, sure. So P over nRT over V, the moles is 0.662. The R is 8.31 liters kPa mole Kelvin times my temperature, which is,
Okay, so if R is 8.3, it's in liters kPa over moles Kelvin. I thought it was in meters cubed kPa over mole Kelvin when it was 8.3.
and the volume is 9.22 decimeters cubed, but a decimeter cubed is a liter.
Yeah, okay. So I was off by a factor of 1,000 then.
Yep. And 273, that would be 289 Kelvin.
Yeah,
Okay?
I can do the math. I just needed the correct
Yep.
R value.
Yep.
Well, I had the correct R value, but I was using it wrong,
Now,
I guess.
Albie, for number 1, they ask for the pressure, but
Yeah.
they don't say whether they want it in atmospheres or kPa. So you can do it in either one. You
Yeah,
could
I'm probably
use-
gonna do it in kPa because that's what I know.
Yeah. So
Awesome.
yeah, same thing. But you could have used the other one if you wanted.
All right, thank you. Goodbye.
Okay. Bye. How you doing? Go for a walk. You got a question, Milam?
Yeah, it's just on one thing for the
Sure.
butane lab. I never really got the barometric pressure. Could I see that real quick?
Oh, sure. Just a second. So that was the one where I did it down here. So we first did this calculation to get 103, and then we subtracted off the vapor pressure to get 100.9. Oh, so if like this is the barometric pressure, if that's what you're looking for. The 103 is the barometric pressure.
Okay, that's because I just wanted to know what I put for the data. That's all I really need
Yep,
to know.
yep, 103.
All right, thank you.
Have a good one.
You too.